Okay, it's the clep, or the AP Calculus at a Glance document. I'd recommend you read through that if you're taking the test. You should always prepare for a test. And what I want to do is go through the sample questions. I'll do it at the whiteboard. But they got a bunch of questions over here, like 1, 2, 3, relatively straightforward, by the way. Some do require some thought, but generally speaking, not much thought in the problems over here. It's a good set of problems to see if you know some calculus. Section 2, the only question in Section 2 that I believe requires a calculator is question number 8, but I'll go through those questions as well. But I will do 8 using a calculator. I don't think I could ever do, I shouldn't say ever, it would be very difficult to do without the use of a calculator. What else? They provide answers for you. If you want to take this opportunity to try it on your own, please do so. You should have access to the document, and of course you have access to this video. So let's go to the whiteboard, and I'll do number 1 at the whiteboard. So number 1, it's a limit problem, and there's one of two ways of doing that, either recognizing it as a derivative or recognizing it as a L'Hopital rule. So let's go to the whiteboard. If I were taking this thing, I have to realize on a multiple choice exam, they are not looking at your work. They're looking at your choice. So anyway, looking at the problem is the limit. This is number 1, by the way, as x goes towards pi from the left side, and then there's a limit. I'm sorry, it is a limit, but it's the natural log of x minus the natural log of pi over, let's see, x minus pi. Nothing tricky about it. So I'm going to have the definition of the derivative. If I did f prime at pi, what would I get over here? Well, if the function f of x is the natural log of x, what would I get over here? The limit as x approaches pi. And then there would be ln x minus ln pi over x minus pi. And that would be the derivative there. Now, certainly, what would that give you? Well, I know the derivative of the natural log of x. I'll write this down for you. It's 1 over x. So what's going to give me? Well, f prime of pi is just simply 1 over pi. All right, that's one way to do the problem over there. What's the choice over there? It's choice B. And I'll go back to the key in a moment, by the way. The other way of doing it is by using L'Hopital's rule. Limit x goes to pi from the left, natural log of x minus natural log of pi, x minus pi, using L'Hopital's rule. And the reason that the limit at the top and the bottom is simultaneously 0. So let's put this down. Take its derivative. Derivative of natural log is 1 over x. Derivative of natural log of pi is 0. And the bottom is going to be 1 minus, well, the derivative of, the derivative of pi is 0. So what do you get over there? Well, it's just very simple limit law problem now. Limit as x goes pi from the left of 1 over x, which would be 1 over pi. So we're getting the same thing. All right, let's go back to the key. And this is, I shouldn't say the key, the test. And I would select B. I want to look at the answer key, though. I want to emphasize that you should be looking at that. And you notice it does say that. All right, so let's do number 2 now. Let's take a look at number 2. Number 2 is also a limit problem. I think I could probably do this one on a piece of paper here. I don't have to go to the whiteboard for that. Let me just get my pen out, and we'll do number 2 now. So I would say, it's equal to something, the limit as x goes to 1. And I remind you again on exams, they're not looking at your work. They're looking at your choice and answer. And the bottom would factor to be x, and then it would be x minus 1. Now that's a little strange, but I'm going to factor out a minus 1 from the first factor on top, by the way. So I get minus 1. Well, if I factor from the first factor, I'd get x minus 1, and then 1 plus x. What do you get in bottom? X minus 1. What happens here, this cancels off because x is not 1. That's what the limit says, by the way. And then I use the limit laws. What do you get over here? Well, you get minus 1, and 1 plus 1 is 2, and at bottom you get 1. So what do you get over there? You get minus 2. Is that answer being listed? It's answer choice A. Let's take a look at the K. And I see that as well. So we're getting these things one at a time. Let's go to the next one. Again, if I go to the whiteboard, I go to the whiteboard. If it's easy to answer, I think I just answer it. I think I could do it here. And the way I would do this one over here, just rewrite it a little bit. And I notice this is x to the 1/2 power. And that's minus 5 over x plus e to the x dx. And I can integrate that quite simply. Power rule, so I add 1 to the exponent. That's 3/2. Whoops, sorry about that. Divide by 3/2, multiply by 2/3. minus 5. Well, that's going to be the natural log of the absolute value of x, natural log absolute value of x. Then when you get plus e to the x plus some constant of integration. And let's see if we see that somewhere. And I think I see it. I think I see it in choice letter B. Let me just make sure that before I circle, I just circled it. 2/3 x to the 3/2. Looks good. Minus 5 natural log of the absolute value of x. Yep. Let's go to number 4 now. Number 4, I'm going to go to the whiteboard to finish that one off. I don't have enough room over here. It's this FFB differentiable function. Well, actually, you know what? Maybe I could fit it in here. And I'll put what I mean by this. I know there's a point on the function, and the point they're given to me is 1, 10. All right? The other thing they tell me the derivative. So I know the slope of the tangent line there. And so I'm going to say f prime of 1. Well, it's going to be what? 1 cubed is 1. 1 plus 15 is 16. The square root of 16 is 4. And what do they want to do? They want to use a linearization at x equals 1, which is just the equation of a tangent line. What's that going to be? Y minus 10, m, which is 4, x minus 1. Let me just rewrite a little differently. Y is going to be equal to 4x. That'll be minus 4 plus 10. Minus 4 plus 10 is plus 6. Right? This is what's known as a linearization of the problem when you're at the point 1. All right, that's a linearization of the problem. What I want to do, use this to approximate the value of f of 1.2. It's going to be an approximate to f of 1.2. And why is that? We're near the value 1, by the way. What's L of 1.2? Well, let's write that down. It's going to be 4 times 1.2 plus 6. Whoops, didn't mean to do that. That's going to be 4.8 plus 6, which is 10.8. So this is going to be the approximate value of f of 1.2. Let's see if that's listed for you. And I do see it. It's choice letter D. What I want to do is go back to the key and look to see if they chose D. All right? I always wonder if I make a mistake somewhere. And you should wonder that too, by the way. So I think 3 was, did I do B? Let me make sure I did that. 3B, make sure I did that. Yeah, I did that. And 4D, make sure I chose D. Yeah, okay. Let's go to 5. And 5 says the function f is defined by this. And it says, what is the slope of the tangent line? And again, I think I could fit the work in over here. So it's going to be f prime. Well, that's going to be 1 over its argument. So 1 over sine x plus 1 times with the inside, which is cosine of x. Where they want to know f prime at 0. Let's plug this in. The cosine of 0 is 1, and the sine of 0 is 0, and 0 plus 1 is 1. So you're going to get 1. What's the correct answer over there? That would be D. So let's make sure 5D is there. Yep, we're going along pretty good here. All right, so far so good. All right. Okay, let's take a look at number 6. And number 6 is a piecewise defined function, and they want to know what k is to make it continuous. Again, I'm not going to write limits down or anything like that, but the bottom line is you got a problem over here, and the problem you got is a parabola looks sort of like this over here, and there's going to be a point up here which is not there, and that's going to be, the point would be 3. And what would you get over there? Well, you get 9 minus 4, which is 5. And again, then there's this cosine function, and we want to make sure it connects to this point over here. So really what we're looking to do is we're looking to say k times the cosine. Oh, we're at the point 3, so it's going to be 3 pi plus 1 would be identical to the number 5, by the way. All right? So what do you do over here? You got to solve it out. And, I want to just remind you the cosine curve, looks like this. This is 1 pi, 2 pi, and 3 pi would be over here. So you're going to get minus k plus 1 equals 5, and that would give you minus k equals 4. That means k is equal to minus 4. And this is an answer you write down the answer in the box. That would be minus 4. Let's look at the answer key. This is 6, and it should say minus 4, and it does. All right, let's go to 7. 7's an implicit differentiation problem. I'm going to go to the whiteboard to do it. Let's go back to the whiteboard. And this is number 7. So number 7, what do I get? I get x cubed plus xy equals 0. They tell me the point in the curve is minus 1 minus 1, which certainly satisfies that equation, by the way, because minus 1 would be the first term, the second term would be plus 1, and that would give you 0. What do they want to know? They want to know dy dx at that given point, minus 1, minus 1. I don't know that. Let's go through that. Implicit differentiation, 3x squared plus, well, derivative of x is 1, so 1 times y plus x times the derivative of y, which is y prime. The derivative is 0, 0. Let's plug it in now. What are we plugging in? Minus 1, minus 1. So you can get 3 minus 1 minus y prime is equal to 0. And you can get 2 minus y prime is equal to 0, or y prime would have to be equal to the number 2. So I'm going to say that I know the derivative now. This is 2. I'm going to go back to the problem set. And I want to see if that answer is being listed. And it is. It's choice D. And let's just check that out, 7D. Oops, sorry about that. 7D. All right, let me go to the next question. The next question is more difficult, and I'm going to go to the whiteboard to do it. And where they say in the next question, you have a curve, another, that's an exponential and a line. There's 2 points of intersection, by the way, and they said, determine the area between those curves, or bounded by those two curves. So I'm going to go to the whiteboard, and I'll talk about that. I would have to use a calculator to do this, by the way. But let me just go to the whiteboard again, and I would do some preliminary work, by the way. And what he mean is you write down, I write down a function f of x equals e to the x. I write another function g of x equals, and what was that? I had to read it's 2x plus 2. What do I know about this over here? Well, I know the e to the x looks like this over here. That's pretty simple. And this is one point that's pretty easy to do. That would be the point 0, 1. And I know what the line looks like. It's got a slope of 2, and it goes through the y-intercept at 2. So I'm going to say something like this over here. This is just a ballpark figure of it. Let me just say there's 2 points of intersection, as they said, by the way. And what do? I got to do this over here. Got to find a point of intersection. So I know what the integration looks like, by the way. The integration looks like there's going to be some lower value here. I'll call that A. And some upper value over here. I'll call that B. A to B. And what do you get over there? The upper curve was what? I got to read that again. It's 2x plus 2. That's the line, by the way. Minus the lower curve in this case, which is just simply e to the x. Let me make sure I'm reading that right, by the way. Dx. The problem with this is I don't know what a and b is to do the integration. If I did, I could do it, and I could write it down, by the way. And this is where a calculator is going to come in handy. So how do you do it in a calculator? I'm going to do it in Sage, and I'll post that video for you. So I'll post the video. But I already did the problem, and the answer turns out to be approximately 2.227. All right? And again, what I do in Sage, I got the A, I got the B, and I actually did the integration using Sage, and I got the number approximately 2.27, right? I will show the Sage work on that later. But right now I'm going to go to the next question. But before I do that, my claim was over here when I did use Sage, and I'll write that down for you. If I use Sage, which I did, Sage is like a computer algebra system. It's like a calculator is what it is, all right, for our purposes. And that was, let's make sure I said that right, by the way, D, all right? And I'm getting that over there. Let's go to problem number 9 now. We're almost done. And number 9, I want to be honest with you, is a related rate problem that you may be confused, but I want to point out they are talking about the area of something, and it's a circle. So I'm going to say area is a function of the radius. And what's that going to be? Pi r squared, all right? So oil is poured on a flat surface. It spreads out, forming a circle. The area of the circle is increasing at a constant rate of 5 square centimeters per second. So really what they're telling me is dA dt is 5. Now if you want to write down, squared centimeters, that's centimeters squared per second, you can. All right, so I'm looking at this over here. I don't know what the question is. It says the rate is the I'm sorry, let me read that again. At the rate, the centimeters per second. Oh, at what rate in centimeters per second is the rate increasing? Well, it's a related rate problem. So dA, by the way, this is what A is. dt is equal to 2 pi r. All right. Do I know what dA dt is? It's 5, 2 pi. And they want to know dA dt at a certain point in time when the r is 5. And I'll put this over here. all right? And that's going to be, I'm sorry, I put to write down dr dt. So that's going to be dr dt now. Can I figure that out? Of course I can. It's going to be 1 over 2 pi. And that's what dr dt. And that's going to be in centimeters per second. Let's take a look at that. Do I see that somewhere? I do. So 9 would give me choice A. Let's just make sure they said that. 9 gives me choice A. Now 10 is probably a question that might confuse some students. And I want to use the picture they're giving me. This is the picture for number 10. And they say the graph is given to me. As I do it, though, I want to point out that your teachers might do it different than me, but I'm looking at this, and this is the derivative. It's the graph of the derivative. So what I'm going to do is right below it is I'm going to write down what this tells me as far as signs go. And so at 1, I get 0. And at 3, I get 0. Now, what do I know about the f prime sign between 0 and 1? It's below the x-axis, so it's a negative curve. It's above between 1 and 3, and I'll go through what that means to me. And after 3, it's negative over here. So I'm going to say it's decreasing, increasing, decreasing. Now, who am I talking about over here? I'm talking about f, all right? I want to go to the concavity of the problem over here. I know something interesting about it. I notice it's concave up here, all right? So I'm going to say at 1, I'm going to say it's concave up here. I'll put a symbol down sort of like this over here. And then it looks like it's concave down. It's between 1 and 3. And then it looks like it's concave up after that, like this over here. And who are we talking about? We're still talking about f, by the way. All right, so let's take a look at this over here. And I have to read each one separately. It says the graph they gave me was of f prime. The derivative function f is shown. I did look at that in the xy plane, which the following statements cannot be true. All right? So this is cannot be true. Well, I'm going to say this one's true because f is decreasing on 0, 1. We just showed that up here, by the way. Let's do the next one. F is concave up between 0 and 1. Well, that's true as well, by the way. I'm looking at that right over here. Now, it says f has a local maximum at x equals 3. Well, let's see if that's possible. Well, you know what? I'm seeing that over there. That's certainly possible. Looks like a maximum. Now, it says D says f has an absolute minimum at 1. Well, that's possible, too, because this looks like a minimum over here. So I can say that's possible. Well, I'm running out of choices, by the way. F has an absolute maximum at 2. Well, let's see what happens. And that's not possible, by the way, because at 2, this thing is increasing on that. So this is not true. So E is the only choice that's not true. Let's take a look at the answer key, and I'm seeing that. We're done. Thank you.